right. So for now, we are gonna be discussing about horizontal asymptotes. Very similar to vertical asymptotes, but this time it's horizontal. So you can see on the right side of the graph, there is one graph right here, and the horizontal asymptote is shown with the green line. So just like the concept in vertical asymptotes, these are lines, imaginary lines that your function, in this case, these are your functions right here. These two curved lines, those are part of the function. They move towards your horizontal asymptote. Like this one right here, as it goes down, it goes towards whatever is that green line, but it will never really cross that line. Also from on the lower graph right here, as it goes towards negative infinity to the left, meaning it moves up towards the horizontal asymptote, but again it will never cross that line. So how to find the horizontal asymptote? On your y-axis, this is the intersection of your the green line and the y-axis. That is the equivalent, whatever is the value of y. Let's just assume that's 2. Okay, so that would be y equals 2. That is the horizontal asymptote. Whatever is this value of y, where your green dotted line crosses the y-axis, that is the value of your horizontal asymptote. In the second graph right here, you have two horizontal asymptotes. The first one here is pi over 2. So that's gonna be, all right, pi over 2 need to, okay, so the first line, this one, and then that one. So the first horizontal asymptote, it crosses the y-axis at this point right there. So that's, you can say that y equals pi over 2. So this is one horizontal asymptote, the top one. And then the second one is y equals negative pi over 2. So in this case, you have two horizontal asymptotes. So now that you have some kind of idea how to find the horizontal asymptote given a graph, I'm gonna be giving you an equation, and from that equation, you will find the horizontal asymptote. But how do we do it? Okay, so we have a guide here. It says to find the horizontal asymptote, we compare the degree of the numerator with the degree of the denominator. Okay, so what is the degree? What's that? Okay, so the degree, this is the highest exponent that you can find in your numerator. Okay, and then of course you will compare them first. Okay, so let's look at this example. Your degree for the numerator is n, and the degree of your denominator is m. So we're gonna compare the highest exponents for your numerator and for your denominator. Okay, now that you have compared them, we have three ways to determine. Okay, so if the degree n is the numerator degree, m is the numerator denominator degree. So meaning if the numerator degree is less than the denominator degree, then your your horizontal asymptote is just plain y equals 0. Okay, what is an example of that? Let's say something like this: f of x equals 2x to the third plus 5 plus 3 over x to the fourth minus 6 plus x to the seventh. Okay, so what is the degree of the numerator? Where the degree of the numerator is 3, the degree of the denominator is 7, because that's the highest exponent. So therefore 3 is less than 7, right? Because, well, those are the degrees. So if this is the case, then your horizontal asymptote, we will call HA, is just y equals 0. That's the solution that they're saying. Okay, now, what about if they have the same degree? Okay, well, if they have the same degree, then your horizontal asymptote will just have this equation: y equals a over b. Now, what is a and what is b? A is the coefficient of the term that has the highest degree and in the numerator, and b is the coefficient of the term that has the highest degree in the denominator. Okay, let's have an example of that. Let's say f of x equals 3x to the fourth minus 6x squared plus 2 over 2x to the fourth minus 3. Okay, so so first we need to compare, we need to check for this one first. What is the degree in the numerator? You have 4. What's the degree in the denominator? You have 4. So therefore n is equal to m, right? So therefore your horizontal asymptote is nothing but the ratio of their coefficients, which is 3 over 2. This is the horizontal asymptote. So the horizontal asymptote is always y equals because it's a horizontal line. Okay. All right. So let's have another example of that. Okay, so another example. Okay, so let's say f of x equals 5x to the fourth plus 3x squared. So this is all over the place now. Equals 3x to the fourth plus 2x squared plus 3x. Okay, so first, what is the degree in the numerator? You look for the term. It has three terms that has the highest exponent. Well, that's gonna be 4, right? And then what's the degree in the denominator? Also 4. So therefore, this is case number 2. They have the same they have the same degree. So therefore, your horizontal asymptote is gonna be y equals the coefficient. Well, this is the term that has the degree of 4. The coefficient there is basically -1. So that's gonna be -1 over the other one is x to the fourth. Here you have 3. All right, so therefore, this is the horizontal asymptote. Okay, so it's not always the first term. You have to look for the term that has the degree so that you can pick the coefficient for that problem. Okay, so now what's the third type? What's the third situation? It says here the third situation is when n is greater than m. Okay, so when the numerator degree is greater than denominator degree, if that is the case, then there is no horizontal asymptote because there is an oblique one. So at this point, we will just worry about telling that they don't have a horizontal asymptote. This will be discussed in a different lesson. Let's have an example. Okay, so let's say f of x equals 5x minus 3x squared plus 2x to the fourth over 2x plus 5x squared. Okay, so what is the degree in the numerator? The highest exponent is 4. What's the degree in the denominator? It's 2. So therefore 4 is greater than 2. Therefore we can say that it's a case number 3. In this case, you will say no horizontal asymptote. Okay. All right. So let's look for some examples, and I'm gonna give you some equations, and you tell me, or some functions, and you tell me which case is it and what is the horizontal asymptote. Okay. So the first one is this. All right. So f of x equals 8x squared over x minus 10. Okay, so what is the what let's circle the degree in the numerator. Well, we only have one term, so that's going to be a 2, and this one right here is just a 1, right? So 2 is greater than 1. Those are the degrees, so therefore we will have case number 3. So in this case, you will say no horizontal asymptotes. Okay, all right, next one. Let's have f of x equals x minus 4x plus 2 all over x squared minus 16. Okay. All right. Well, in the numerator, let's find the degree. We'll have x and 4x. That's both 1. So that means it's 1. Okay. That's the n. And then in here you have 2. So you can say that n is less than m, right? Because 1 is less than 2. So therefore, that is case number 1. Then you will say your HA, therefore, is y equals 0. Okay. All right, number 3, let's have f of x equals 5x squared plus 6x minus 2 all over 2x squared minus 8x minus 6. All right. So what's the degree? The degree here is 2. The degree here is 2. Therefore, you can say that n is equal to m. In that case, that's situation number 2. So therefore, you can say that your HA is y equals, well, what's the coefficient of this term? That's 5 over the coefficient of this term. That's 2. This is your horizontal asymptote. All right, so I will see you next time. If you have any question, always just send a message in the comment and I will get back to you.